Hey guys, this is Micah with the Modern Einstein. Today I'm going to be doing a Science Talk segment. We're going to be working with physics, and I'm going to teach you a little bit on how to resolve a projectile into its parts. So if you take a look over here at the board, I have a written out equation. Right now it kind of looks like Greek, but I'll explain it to you here a little bit better. If you look over here at this right triangle, I have set up a scenario. You can see this 100 meters per second. I've set up a scenario where we have a train traveling 100 meters per second, or not a train, a plane traveling 100 meters per second. We can see this horizontal line right here being the ground. So we can see that the plane is taking off at a 45-degree angle, and we can fill in the rest here, this being the height, V standing for velocity, Y standing for the Y direction, which means height. So we can say that this variable would be our velocity in the Y direction, this would be the velocity in the X direction. So what do we know, having said that? We know our speed, our angle, and our two variables right here. If you look up here at this nonsense, it's pronounced SOHCAHTOA. If you split it into parts, we can use this for an acronym. We can say S stands for sine, and sine we get from opposite divided by hypotenuse. Cosine we get from adjacent divided by hypotenuse. Tangent we get from opposite divided by adjacent. So these are our basic trig ratios that we're going to use to be solving this problem. If you look over here, I have, just like I have over here, sine equals opposite over hypotenuse. So we have the sine of our angle equals our opposite, which in this case is our velocity in our Y direction, divided by our velocity in general, which is our hypotenuse. Take it down a step and let's actually plug in some numbers. We have velocity in the Y direction is equal to sine times theta, which we know is our angle, 45 degrees, times our velocity. Again, we're following this equation up here. Our velocity is 100 meters per second. You can plug this into the calculator just like this. You have a sine button. And when you plug that in, you get that our velocity in the Y direction is equal to 70.71 meters per second. Now, if you can get that, you can certainly get this other part. We're just using a different ratio. If you look up here at the CAH, we see our cosine is equal to our adjacent over our hypotenuse. Again, I drew out the equation. The cosine of our angle is equal to the adjacent, which is our velocity in the X direction, divided by our hypotenuse, which is the velocity. Go down a step, I just plug in the numbers at this point. Our velocity in the X direction is equal to the cosine of our 45-degree angle times our 100 meters per second. And again, we get our velocity in the X direction is equal to 70.71 meters per second. Now, if you notice, our velocity in the Y direction and the velocity in the X direction we have found to be at equal values. And if you look over here at this diagram, we see that this is at a 45-degree angle. And when it's at a 45-degree angle, we know that both of our velocity in our Y direction and our velocity in our X direction will be equal because of that 45-degree angle. However, if that angle would change, then our components of that flight pattern would change. This has been a Modern Einstein production. I'm Micah, and if you need any help with this, just email us, leave a comment, or anything like that. So glad to help you guys. Hope to see you in other videos. See you guys later.